In today's video, I am going to teach you about operators and expressions in Kotlin. Hello and welcome to Learn with Tam. I'm Tarique Ali Mirza and my goal is to make you a kick-ass Android developer. If you are new here, I suggest that you watch this series from the beginning to get the most out of it. In the previous lecture, I covered the concept of nullability in Kotlin. It was a lot of information to take in. So, please make sure that you understand everything that I taught in that video before continuing further. That being said, in today's lecture we are covering operators and expressions in Kotlin. So, without further ado, let's jump right into our system and get started. As always, let's open Android Studio. Now click on Create New Project. Select No Activity, then click on Next. Give your project a name, then click on Finish. Once the project is ready, go to your Project Explorer and open the App folder, then open the Java folder. And then right-click on your package folder, select New, then select Kotlin file. Give your file a name and press Enter. Now create the entry point function. So far, we have covered topics like variables, data types, and nullability in Kotlin. Knowing how to create variables gives you the power of storing data in your Kotlin programs. The next logical step is to learn how to work with those variables. We use operators and expressions to work with variables. You have already seen some of these operators and expressions while I was going through the various examples in the previous lecture. Let me first write some code so that I can explain what I mean by operators and expression. You can see three different expressions on line 4, 5 and 6. They are val a equal to 10, val b equal to 20 and val sum is equal to a plus b. On line 6 in particular, you can see that I am assigning the value of a plus b to the variable sum. Here, a plus b is an expression and I am assigning the result of that expression in the variable sum. The operator that I am using to add those two values is known as the addition operator, whereas the operator that I am using to assign that value to sum is known as the assignment operator. Let us first look at the assignment operator in detail. The assignment operator requires two operands, one on the left hand side and one on the right hand side. In our example on line number 6, we have sum on the left hand side and a plus b on the right hand side. In most of the cases, the right hand side operand will be an expression. You can see me using the assignment operator on line number 4 and 5 as well. On line number 4, a is the left hand operand and 10 is the right hand operand. On line number 5, b is the left hand operand and 20 is the right hand operand. And I am using the assignment operator to assign the value 10 to A and the value 20 to B. Let me show you a couple of other examples as well. As you can see, I have written 3 examples to explain the usage of assignment operator. In the first example, on line number 12, you can see that I am assigning the value 32 to the variable age. In the second example, on line number 13, you can see that I am using the expression age plus 5 and assigning it to age after 5 years. In these 3 examples, all I am trying to show you is that you can assign a value to a variable using the assignment operator, or you can assign the result of an expression to a variable using the assignment operator, or you can assign the value stored within another variable using the assignment operator, among other things. Let me now run this code so that you can see the output. The value 30 that was printed on the console is from the first print statement on line number 9, where we are printing the sum of a plus b. On the next line, you see the output for the print statement on line number 16. It says that age is equal to 32, which is exactly what we stored in age. Age after 5 years, which is age plus 5, is 37. That is also correct. And another age is equal to 32, which is also correct because we stored the value of age within another age. These three examples are more than enough for you to understand the usage of assignment operator. So, let's move on to the arithmetic operators. To write mathematical expressions in Kotlin, we can make the use of arithmetic operators. Let me show you a few examples. On line number 19 and 20, I have declared two mutable variables x and y and stored the value 10 and 3 within them. I will use these two variables to demonstrate the usage of various mathematical operators in Kotlin. First, we will look at the binary operator. Binary operators are those operators which require the use of two operands, one on the left hand side and one on the right hand side. On line number 23, you can see the first such mathematical operator, that is the addition operator. We have already used this operator multiple times within our programs in various lectures. As you can see, the addition operator requires an operand on the left hand side as well as an operand on the right hand side. This operand can either be a single variable or an entire expression. The addition operator simply adds the right hand operand to the left hand operand. The subtraction operator simply subtracts the right hand operand from the left hand operand. The product operator simply multiplies the left hand operand with the right hand operand. The division operator divides the left hand operand with the right hand operand. And the remainder operator on line number 27 simply gives the remainder that is found after dividing the left hand operand with the right hand operand. Now, let us run this program to see the output. But first, let me comment the code that I had written for previous examples. Now, I will run the program. 10 plus 3 is equal to 13, which is fine. 10 minus 3 is equal to 7, which is also correct. 10 into 3 is equal to 30, which is also correct. 10 divided by 3 is equal to 3. Shouldn't that be 3.3? We'll come back to that. 10 modulo 3 is equal to 1, and that means that the remainder when you divide 10 by 3 is equal to 1. All of these operations happened exactly as we expected them to happen. So I guess you understand the different mathematical binary operators. Now let us look at the mathematical unary operators. As you can see, I have written a few examples of unary mathematical operators. The first one among them is the negation operator, which simply negates the value that is provided to it. For example, on line number 32, I am creating a variable named negative x and storing the value of minus x within it. The minus before x is the negation operator. It simply negates the value that is provided to it. As you can see, this operator is using only one operand on its right hand side, and that is exactly why it is called a unary operator, because it operates on only one operand, unlike binary operators which require two operands, one on the left hand side and one on the right hand side. On line number 33, I am creating a variable named negative y and saving the value of negated y within it, using the negation operator before y once again. After that, we are using the increment operator to increment the value of x and y. On line number 34 and 35, the increment operator simply increments the value stored within the variable by 1, and the decrement operator simply decrements the value by 1. Let me show you the decrement operator as well. As you can see, I am using the decrement operator first on x on line number 39, and then on line number 40, I am decrementing the value of y using the decrement operator. And on line number 42, I am printing the values of both x and y after they have been decremented. Let me run this program so that you can see the output in the console window. Let me comment the print statement from the previous example first. And now I will rerun the program. As you can see, the value of negative x is minus 10. Negative x should contain the negative value of x. And since x was 10, negative x is minus 10. Negative y should contain the negative value of y. Since y was 3, the negative y value is minus 3. Now, let's see the values of x and y after they have been incremented. The value of x is 11 and y is 4 because x was 10, after incrementing it by 1, it became 11. And y was 3. After incrementing it by 1, it became 4. On line number 39 and 40, we decremented the values of x and y. And then when we print it, we see x is equal to 10 and y is equal to 3. The values in the previous print statement were x is equal to 11, which means after decrementing x, we get 11 minus 1, which is 10. That is correct. And decrementing y from 4, we get 3. That is also correct. As you might have noticed, the mathematical operators are doing exactly what they do in mathematics. Moving on, in some of the cases, it is required that we store the result of a mathematical operation in one of the operands. Let me show you an example. As you can see on line number 44 and 45, I am trying to store the result of the mathematical operation within one of the operands. If you look at line number 44, one of the operands is x and I am storing the result in x as well. On line number 45, one of the operands is y and I am storing the result in y as well. For such cases, Kotlin gives us augmented assignment operators to make our life easier. Let me show you how we will write the same statements using augmented assignment operators. On line 49, you are seeing the first example of augmented assignment operator. The plus equal to operator simply adds 10 to the value of x and then stores the result within x. The multiply equal to operator on line number 50 simply multiplies y by 5 and then stores the result within y. Let me now run this program so that you can see the output after these two operations. For better understanding, let me print the value of x and y before the operation as well. And I'll comment out the code that we don't need as of now. Now let's rerun the program. As you can see, the value of x before that operation was 10 and the value of y was 3. After the operation, the value of x was added with 10 and the value of x became 20. And y was multiplied by 5, the value of y became 15. Everything is working as it is expected to work. Now, I will write down the code to demonstrate the usage of rest of the augmented assignment operators. As you can see, on line number 54, 55 and 59, I have used 3 other augmented assignment operators. On line number 54, I am using the minus equal to operator, which simply deducts the value of 10 from x and then stores the result within x. On line number 55, I am demonstrating the usage of divide equal operator. It will simply divide the value of y by 5 and then store the result within y. On line number 57, I am printing the value of x and y after the operation. On line number 59, I am showing the use of modulo equal to operator. It will simply divide x by y and take the remainder and store that value within x. On line number 61, I am printing the value of x and y after this operation. Let us now run this program so that you can see the output. As you can see, the initial value of x was 10 and y was 3. After the first operation, that is x plus equal to 10, the value of x became 20. And after y multiplied by equal to 5, the value of y became 15. After x minus equal to 10, that is, the current value of x is 20, 20 minus 10, we get x is equal to 10, which is correct. The current value of y is 15, 15 divided by 5 is equal to 3, that is also correct. Now, after x modulo y, we get x is equal to 1 and y is equal to 3, because we did not change y in this operation, and the remainder of 10 divided by 3 is 1. Because 3 times 3 is 9 and 10 minus 9 is 1. So, the remainder of 10 divided by 3 is 1. So, the value of x after this operation is also 1. Now, let me comment out all of this code so that I can demonstrate the usage of logical operators in Kotlin. Kotlin also gives us a set of logical operators to help us compare different types of data. For example, if we wish to compare whether one number is greater than the other number or whether one number is less than the other number, then we can compare them using the logical operators. Let us look at some of the examples. As you can see, on line number 64 and 65, I have created two variables to demonstrate the logical operators in Kotlin. On line number 67, I have created another Boolean variable to store the result of my first logical operation. On line number 68, I am using the less than logical operator to check whether x is less than y or not, and storing the result in the result variable. On line number 70, I am printing the value stored within result. Let me run this program so that you can see what is happening. As you can see, the value stored within x is 10 and value stored within y is 5, and the result variable contains the value of the logical operation x less than y. X is 10 and y is 5. 10 is not less than 5. Therefore, the answer to x less than y is false, which is exactly what we see right here. Let me change this print statement to print the value of x and y instead of printing x and y. Now let's rerun this program. As you can see, now it is printing 10 less than 5 is false, which is exactly what we expect. Now, let us look at some other logical operators. As you can see, from line number 72 to 78, I am using string interpolation. On line number 72, I am checking whether x is greater than y. On line number 74, I am checking whether x is equal to y. On line number 76, I am checking whether x is less than or equal to y. On line number 78, I am checking whether x is greater than or equal to y. Let us run this program so that we can see the result of each of these logical operations. As you have already seen, 10 less than 5 is false. 10 greater than 5 is true. 10 equal to 5, which means that 10 is equal to 5, is false because 10 and 5 are not equal. 10 less than or equal to 5 is false because 10 is neither less than 5 nor equal to 5. 10 is greater than or equal to 5 is true because 10 is greater than 5. Now, let me change the value of x and let's see how the output changes because of that. I will make x equal to 5 and rerun the program. The less than operator checks whether the operand on the left hand side is less than the right hand side. In this case, it is false. The greater than operator checks whether the operand on the left hand side is greater than the operand on the right hand side, which in this case is again false. The equal to operator checks whether both operands are equal, which in this case is true. The less than equal to operator checks whether the operand on the left hand side is less than or equal to the operand on the right hand side. Similarly, the greater than equal to operator checks whether the operand on the left hand side is greater than or equal to the operand on the right hand side, which in this case is again true. As you can see, all of these logical operators are binary operators because they require two operands. Now let us look at the Boolean logical operators in Kotlin. The Boolean logical operators in Kotlin take Booleans as their operands and return Boolean as the result. Let me show you an example. On line number 81 and 82, I have created two variables x and y with values 10 and 5. On line number 83, I am showing the use of the first Boolean logical operator, that is the not operator or the negation operator. On line number 83, we are checking whether x is greater than y or not, and whatever result we get, we use the negation operator to invert it. Let me show you the output. Now I will run the program so that you can see the output. X is greater than y is true because 10 is greater than 5. But since we are negating the result, we are getting false because inverse of true is false. Let me show you another example to make this clearer. As you can see, on line number 87, I am using the negation operator to negate the value of true. Let us see what the result is when we print this. Negation of true is false, which is exactly what we expect. So, as you have seen, the negation operator simply takes a Boolean as an operand and inverts its value. So, if an expression is true, the negation operator simply makes it false. If an expression is false, the negation operator makes it true, as we have seen in this example on line number 87. Now, let us look at the other two Boolean logical operators, the AND and the OR operator. I will explain both of them with the help of examples. On line number 89, I am demonstrating the use of the OR operator. The OR operator takes two operands and all it does is that it checks whether one of those two operands is true or not. If even one of those two operands is true, then it gives the result of true. If neither of those two operands are true, then it gives the result as false. Now let's look at the AND operator that I have demonstrated on line number 91. The AND operator takes two operands and checks whether both of the operands are true or not. If both of the operands are true, the result is true. Otherwise, the result is false. As we can see, on line number 99, both of the operands are true. So, the result should be true. On line number 89, one of the operands to OR operator is true, so the result should also be true. Let me run this program so that you can see the output. As you can see, true or false is equal to true, which means that if either of the two operands is true, the result of an OR operation is true. In the last printed output, the AND operator checked whether the left-hand operand and the right-hand operand are both true or not. And since they were both true, the result came down to be true as well. Let me write down two more cases for you to see. As you can see, on line number 93 and 95, I have written two more cases. For an OR operator, when neither of the operands are true, the answer is false. And for an AND operator, when either of the operands is false, the answer is false. Let me run this program so that you can verify the output. As you can see, when neither of the operands for an OR operator were true, the answer came down to be false. In case of the next operation, that is true and false, the answer was also false because the AND operator wants both the operands to be true in order to give true as a result. The last operator we are going to cover for this video is the range operator. The range operator helps us declare a list of numbers by providing the starting point and the end point of the list. Let me show you an example. As you can see, on line number 98, I have declared a variable named numbers and I have stored 1.10 in it. The dot is nothing but the range operator. So we are creating a list of numbers from 1 to 10 using the range operator. The left-hand operand to a range operator is the starting value or the minimum value of the list. The right-hand operand of the range operator is the maximum value or the ending value of the numbers list. Let me now run the program so that you can see the output. It is simply printing 1.10 instead of printing a list of numbers. I will have to change my print statement a bit so that we can see a list in the output. I am using the toList function to convert this range to a list that we can see in the printed output. Let me rerun this program so that we can verify if it is working. As expected, we get a list of numbers from 1 up to 10. Although we have not studied list up to now, don't worry, we will be covering list in a later video. But as of now, it is enough to know that a list is a collection of values of the same type. As you can see in the output, we have a list of numbers. With that small topic out of the way, now we have covered everything you need to know about operators and expressions in Kotlin. In the previous video, I used if and else multiple times to bypass the restrictions imposed by the Kotlin compiler on my nullable variable. But I did not get into the details of how if and else work because they will be covered in the next video. That's all for today's video. As always, feel free to share your valuable thoughts and feedback in the comment section. If you liked the video, smash that like button. If you are new to the channel, consider subscribing. And don't forget to hit the bell icon to receive timely updates of all future uploads. I'll see you in the next one.